Okay, in this lesson, we're going to talk about angle pairs, and we're going to look at a couple of theorems that involve these angle pairs. Okay, make sure you're filling in your flashcards and putting these in your notes as we go through our 4 different angle pairs today. So, first off, complementary angles. We've seen this one before. It's 2 angles whose measures sum to 90 degrees. So if you take any 2 angles, for example, angle 1 and angle 2, as long as their measures add up to be 90 degrees, then they are complementary. Okay, we've got another example here. Angle A and angle B. 40 plus 50 is 90. So A is the complement of angle B, is another way to say that they are complementary. Okay, our second angle pair, supplementary angles. Supplementary angles are 2 angles whose measures sum to 180 degrees. So make sure that you pair complementary in your brain with 90 degrees, supplementary with 180 degrees. All right, here's a couple examples here. We've got this diagram. We've got angle 3 and angle 4. Since they, in a sense, form a straight line, we've got this 180 degrees from here to here. Got a book that's wide open. Then angle 3 and angle 4 are supplementary. Also, we've got angle C and angle D. C is 75, D is 105. Adding these together, we get 180 degrees. So angle C is the supplement of angle D. Okay, our next angle pair is adjacent angles. Adjacent angles has a long definition, says 2 coplanar angles with a common side, a common vertex, and no common interior points. Okay, what that means is that they're side by side, they share the same vertex, and they don't overlap each other. So we've got angle 5 and angle 6 here, real similar to our supplementary diagram. But they're side by side. They share this side, this ray here. This is their common vertex, and they don't overlap each other. Okay, another pair here. They don't have to be supplementary. They can just be side by side, common endpoint. They share this middle side, and they don't overlap. Angle 7 and angle 8 are also adjacent angles. Okay, our last angle pair for today, vertical angles. We're going to be using this one a lot as well. Vertical angles are 2 angles whose sides are opposite rays. Okay, so remember opposite rays from Unit 1. We said 2 opposite rays have the same endpoint and they're going in totally opposite directions. So if you stick them together, you form a straight line. So if we look at angles 1, 2, 3, and 4, then we've got 2 pairs of vertical angles forming. Okay? Anytime actually we've got 2 lines that intersect, we've got 2 pairs of vertical angles. So let's look. We've got angle 1 and 3 are vertical angles. We've also got angles 2 and 4. So notice they have the same vertex and their sides are opposite rays. So angle 1 here has sides here and here. Its sides are opposite rays with angle 3, whose sides are here and here. Okay, it turns out that vertical angles are congruent to each other. So anytime we have a pair of vertical angles, they have that same measure. So angle 1 and angle 3, we could say those 2 angles are congruent to each other. We can mark it on our diagram with our arc marks. Our other pair are congruent to each other as well. Angle 2 is congruent to angle 4. Okay, so they're also congruent. Now, notice that angle 1 is not necessarily congruent to angle 2, but only the pairs of vertical angles are congruent to each other. Okay, now let's look at a couple of theorems. Now, a theorem is a conjecture that is proven, so we can accept it as truth. It has been proven in the past. First one we're going to look at says, if two angles are supplements of congruent angles or of the same angle, then the two angles are congruent. Okay, we've got an example here. We've got angle 1, 3, and 2. If we know that angles 1 and 2 are supplementary, and we know that angle 3 and 2 are supplementary, then we can conclude, according to this theorem, that angle 1 and angle 3 are congruent to each other. Okay, so we could add to our diagram angle 1 and angle 3 must be the same angle. Because if these two add to be 180 and these two add to be 180, this number didn't change, so these have to be the same number. Okay, similarly, in our next theorem, says if two angles are complements of congruent angles, so remember complementary 90 degrees, or of the same angle, then the two angles are congruent. So we've got angles P, D, and F. If P and D are complementary angles, and F and D are complementary angles, then this theorem tells us that angle P must be congruent to angle F. Okay, two more theorems, and then we're done with this lesson. All right angles are congruent. Makes sense, right? We know that right angles have a measure of 90 degrees. Any other right angle also has a measure of 90 degrees. Same measures, same shape, means that they're congruent. So any flavor of right angles that we come across, they're all going to be congruent to each other. So angle C, angle E, and angle F are all congruent. Last theorem says if two angles are congruent and supplementary, then each angle is a right angle. Okay, so let's look at our diagram here. We've got angle 9 and angle 10. So we're given that they're congruent. We've got our arc marks. And by the diagram, we can tell that they're supplementary because they form this straight angle here. So let's think about this. If they're the same measure and, so congruent means same measure, and they're supplementary, which means they add to be 180 degrees, same number added to itself to make 180, there's only one number that fits that description, and that's a 90-degree angle. So if we know 9 and 10 are supplementary and congruent, then they must be right angles. So not only are they congruent, they're also right angles. Okay, so these 4 angle pairs, very essential. Make sure that you put these on flashcards. Make sure that you study these for our test. Unit 2.